All right, ladies and gentlemen, welcome back to another lesson. Today we're going to actually talk about some stuff that we have already seen. We're just going to kind of go a little more in depth on what we're looking at with these. Our eventual goal here is to combine all the rules and laws we've talked about so far with exponents, and we'll start to see that next week. But for right now, we're really just looking at what we're going to call the zero exponent and the negative exponent. And again, we've already seen this a little bit, especially when we talked about the division law. However, I want to just show you a little bit about what's going on. First off, the zero exponent. We've already talked about how anything to the zero power equals 1. So like if I take 6 to the 0 power, that's going to equal 1. If I take, a watermelon, I don't know if I can draw a watermelon, there we go, to the 0 power, that's going to equal 1. It doesn't matter what you take to the 0 power, it will equal 1. Okay, but just to kind of do a little bit of a thought experiment, to kind of look at maybe some patterns that we could do to help figure out why that's the case. Because as we said before, it doesn't really make sense why it equals 1, but let's kind of look and see, and maybe we can see why. If I look down here, I gave some patterns here. I said here's 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. What I want you to do is I want you to fill out what each of these equals. Okay, I want you to go ahead and fill out what each of these equals. So, for example, in this column here, I want you to do, all right, we'll wait on E. We'll do the rest of them. But 2 to the 1st, all right, that's 2. 2 to the 2nd, that's 4. 2 to the 3rd, that's 8. And 2 to the 4th, that is 16. I want you to do this for all of these columns, so do it for the next two. And then I want you to see if you notice a pattern if you kind of go from A down to E. What do you notice is happening as we go from each step to each step? So in a second here, go ahead and pause the video and fill all this out, and then see if you can come up with a pattern of what's going on. Then come back and check back with me and see if you agree with the pattern that I come up with. Alright, so hopefully you went ahead and you did this, and you might have noticed a pattern. In this first one that we did, hopefully you noticed that as we go from A on down to D, we are dividing by 2, right? So we're doing, alright, divide by 2, then we'll divide by 2, then we'll divide by 2. We're dividing by 2 each time. That's kind of the pattern that shows up as you go from the top to the bottom. If I continue this pattern, I divide by 2 again, 2 divided by 2 is going to give me 1. Oh, 2 to the 0 power must equal 1 if I want to keep that pattern up. Same thing over here. I can see if I keep going down, I'm actually dividing by 4. Okay, so divide by 4, divide by 4, divide by 4. And if I keep that pattern up and I do it again for the last one, I'm going to get that 4 to the 0 equals 1. Once again, I'm dividing by 4 each time. Oh, 4 to the 0 must equal 1. Same thing over here. I can see that I can divide by 5. Divide by 5, divide by 5, divide by 5. And I can kind of see that that pattern again is going to hold true. If I divide by 5 again, I'm going to get 1. This is sort of using a pattern to kind of recognize why the zero exponent is going to equal 1. Now, we've already briefly talked about this, but just to kind of get it into formal speak so we kind of have it in our notes, any number raised to the 0 power is 1. Okay, 3 to the 0 is 1, 8 to the 0 is 1, okay, anything to the 0 power is 1. Even when we're talking about 0 to the 0 power, even though 0 sometimes messes up stuff for us and is weird, 0 to 0 power is still 1. It doesn't matter what it is. If you take it to the 0 power, you get 1. Again, up at the top, we said watermelon to the 0 power is 1. Anything to the 0 power will give you 1. Okay, so for example, you're going to see, and this is kind of like the trick they like to do. They'll give you these problems where they have these like crazy things going on. They have fractions, they have a bunch of variables, all this nasty stuff, and it'll say to the 0 power. And you don't even have to think, you just jump for joy because it's easy as pie. Like A here, A to the 4th is 0. That's going to equal 1. Anything to 0 power equals 1. How about this one B? 1/2 to the 0. Going to equal 1. Anything to the 0 power equals 1. How about A to the 3rd over A to the 0? I can start using my exponent laws and simplifying this. I don't have to do that. It's to the 0 power. I know it's going to equal 1. Whenever you see something raised to the 0 power, jump for joy. It makes it a whole lot easier. Now, we've talked about negative exponents before and about how we kind of move them to the denominator. But a lot of you probably had some questions about, well, what does that mean? Why does that happen? How does that happen? Let's just take a look real quick and kind of do the same thing we did before by going ahead and doing a pattern here. So if I have 2 squared, I know that equals 4. Okay, cool. If I have 2 to the first, then it equals 2. We just set out 2 to the 0 equals 1. Now, if you remember, I'm getting these numbers by dividing by 2 every time. I'm dividing by 2. So if that's the case, and I'm dividing by 2, if I keep that up, I can get what 2 to the negative 1 equals. That's going to equal 1 over 2. And in fact, I can divide by 2 again to get what 2 to the negative 2 equals, and that equals 1 over 4. But I'm actually going to change how I write this to kind of show you what's going on here. It's not even just 1 over 4. I could rewrite this if I want to as 1 over 2 squared. Do you notice how the negative exponent is now in the denominator? It switched sides from the numerator to the denominator to become positive. That's really the key here with this exponent law with negative exponents, is that moving it to the denominator. Okay, I do the same thing here with the 4s. 4 to the second, that's 16, cool. 1 over 4, I just divide by 4, I'm going to get 4. 4 to the 0, I know that's 1. Again, I just divide by 4. If I divide by 4 again, I get 1 over 4. You'll notice how this is 4 to the first in the denominator. 4 to negative 1, move the denominator. And then this one, I'm going to get 1/16. Or if I want to think of it in terms of my exponent laws, it's the same thing as 1 over 4 squared. All right, so it kind of makes sense for following that same pattern, dividing by 4 each time. Same thing over here. I'm going to have 25. I'm going to have 5. I'm going to have 1. Oh, when I put this in the denominator, I get 1/5. And then I'm dividing by 5 again. I get 1/25, which is the same thing as 1 over 5 to the second. All right, so I can kind of see that pattern and why my negative exponents go to the denominator just by following this pattern. Okay, so any number to raise to the negative power can be rewritten as 1 over 3 to the second, or if I want to write it generically, 1 over a to the nth. I move it to the denominator. Okay, move it to the denominator. All right, so that's your notes for tonight. That's what I want you to write down, is have this stuff coming in. We'll talk about what it looks like with negative exponents and the 0 exponent more tomorrow. But make sure you have these written down. I hope you guys have a nice night.